we're going to do the methyl red test. The methyl red test shows if our organisms can undergo fermentation processes that change the pH such enough that we get a bright red color in our media. Now this drops the pH quite a bit, so there should be a lot of acid in the tube. So let's see what happens when we add our methyl red to our bacterial tubes. We're going to add 7 drops.
That was probably about 6. All right. Not an exact science when I'm doing it. 2, 3, 4, 5, 6, 7. Right. Come on, you. This is embarrassing. Let me loosen this guy.
Some of the tubes are hard to open.
There we go.
Okay, so let's look at our results. So our first tube, Ethan is going to hold up. This is Enterobacter, and it didn't turn a bright red color. It stayed orange, so this tells me that my organism probably isn't undergoing mixed acid fermentation. Let's take a look at the E. coli tube. See how this is a nice red color? This shows me that the pH dropped enough to indicate that this organism can undergo mixed acid fermentation. Now let's check out your unknown. You be the decider. What do you think? We're going to do the VP test. The VP test is another fermentation pathway. Now, this tests for whether we can utilize butanediol or acetylene or acetoin, depending on who you talk to. Now, for this test, we need alpha naphthol and potassium hydroxide. We're going to add 16 drops of alpha naphthol, 5 drops of potassium hydroxide to all 3 of our tubes, and then we have to shake them for 5 minutes. So we're adding the alpha naphthol first. Notice the media gets really cloudy. This is kind of fun.
That's right. That's too much. Just trying to pick up some. Can't touch it. All right.
So we've added our alpha naphthol. Now we're going to add our 5 drops of KOH, or potassium hydroxide. Notice when we add it, the media starts to clear back up. Now comes the fun part where we shake gently for 5 minutes. We're going to pick up our tubes, hold them all in the same hand, and we're just going to shake for 5 minutes. Now while Ethan's doing this, we're gonna pause and make another video. Now normally when you're doing this, you do not get up and move from your seat, so just be aware of that. Now we're going to focus on the nitrate test. Now we're going to start the nitrate test. We have sulfonilic acid and alpha-naphthylamine. Our bottles labeled them nitrate A and nitrate B. So we're going to add 5 drops of each reagent, starting with nitrate A, to each of our tubes, and then we're just going to let them sit for 10 minutes. Now that our reagents are added, we're just going to gently shake them just for a little bit, just to make sure that they're mixed. And now we're just going to let them sit for 10 minutes. So we'll come back and check on the MR, the VP, and the nitrate in just a little bit. Next, we're going to move on to catalase and oxidase. Andrew is working on the catalase test. For this test, we look to see if our organism has the enzymes to break down hydrogen peroxide into less harmful forms of oxygen. And so we have a bacterial slide that we have made circles on, and all we're going to do is we're going to grab some of our bacteria, and then we're going to put that directly on the slide within our circle. No water drop needed. And then, of course, we're going to flame our loop, comfy cozy like. You have to be careful. No aerosols. And so, holding our loop up for 10 minutes. Actually, it's seconds, but sometimes it feels like minutes. And then coming down into our flame carefully. And then we're going to get our next bacteria, which is actually from a plate. So we can actually open the plate, pull our loop where there's not any bacteria, and then pick up bacteria from a single colony on the plate, touch that to our second circle, and then flame. So our first circle has E. coli in it, our second circle has Enterococcus, and then our third circle is going to have the unknown. So Andrew's almost finished flaming his loop. So now we're going to add the unknown. A little bit. Flame. Tap. Touch our loop to our slide. And then flaming our loop, comfy cozy, holding our loop way up top. Now we're actually going to spray hydrogen peroxide very carefully on the slide, and we're going to look for bubbles. Okay, so notice E. coli started to bubble. Our Enterococcus, there's no bubbling, and you decide what happened to the unknown. Now we're going to do the cytochrome oxidase test. In the cytochrome oxidase test, we're looking to see if our organisms actually have cytochrome C within their electron transport chain. This is very important and allows more hydrogens to be moved across the membrane during oxidative phosphorylation. And so the way we do this is we have our cotton swabs. We're going to get bacteria on the end of the cotton swab, and then we're going to add a drop of our oxidase reagent. If the cotton swab turns blue, then our organism has cytochrome C. And so we're going to start with E. coli. We're going to get a small amount of bacteria on our cotton swab. And then we're going to add our drop of oxidase reagent. And wait about 10 seconds and see if we get a color change. I'm not seeing a color change for E. coli, so that means we don't have cytochrome C.
Put this on bleach beaker for me. Thanks, Andrew.
Our cotton swabs go in the bleach beaker when we're done, and Andrew has nicely helped Ethan get his cotton swab to the bleach beaker.
He's a good friend.
So now we're going to do the Pseudomonas, and we just have a plate of Pseudomonas, so we're just going to pick up a couple of areas, and now we're going to add our cotton swab oxidase reagent and see what happens.
Sometimes you squeeze a little bit. I might have got a little bit, but I'm not really sure. There we go.
So if you notice, we're already, with just a few seconds, getting a nice blue color. So this tells me Pseudomonas has cytochrome C. Now let's check out your unknown.
You just broke this one, right?
Mm-hmm.
Let me use my dominant hand. Oh. Does that ever happen?
Yes.
We had a breakthrough that I mostly missed. There we go.
Okay, so we've added our oxidase reagent. And do you see any blue? Let me know. Going back to our nitrate test. Notice none of them are currently red. So we're going to add some zinc dust to each tube and wait just a couple of minutes. We just add a small amount. Zinc is a catalyst that actually takes nitrate and converts it to nitrite. And that would actually cause a pink color to form. If there's no pink color, there wasn't any nitrate left in the tube for us to convert. So we're just going to hang out and wait and see if any of our tubes start turning pink. Now we're going to check out our VP tubes. Now notice Our Enterobacter has a nice red layer at the top. This shows me that this organism can utilize butanediol or acetoin. Our E. coli stayed clear or yellow, so this tells me that we prefer a different pathway. And if you remember our MR test, our E. coli was bright red. So this shows me that E. coli prefers the mixed acid pathway instead of the butanediol pathway. Here's your unknown. You tell me, what do you think? So we're back to our nitrate test. And if you notice, both E. coli and Enterobacter stayed clear. This means that nitrate was reduced to something beyond nitrite. So the zinc wasn't able to find any nitrate to reduce, so we didn't turn pink. Now over here's your unknown. What do you think? We're going to go over some of the results of the test that you did yesterday. And so I'm going to start with your OF test. Remember, these tubes started green. And so we're going to start with your E. coli. And notice for these, both the fermentative tube and the oxidative tube turned from green to yellow. This tells me that my organism is fermentative. Now remember, if only the O tube changes to green or changes from green to yellow, that means our organism would be oxidative. But if neither change, that means our organism is non-saccharolytic. So based on that, what do you think your unknown is? Come check your results of your own when you have time and see if you got the same thing. Next, we're going to do the lactose test. Remember, these are purple broths where we add different sugars. And in this case, our lactose test for E. coli went from purple to bright yellow. This shows me that our organism can ferment lactose and even made a little gas bubble in our Durham tube saying that it can produce gas during fermentation. So that's pretty fun. So let's look at your unknown. What do you think? Now, E. coli could utilize lactose, but for some reason, our inositol is still purple. So E. coli can't utilize inositol for energy. What do you think about your unknown? Is it yellow? Our next test is the ONPG test. Remember, this shows us if we have beta-galactosidase. These started clear. Now, our Enterobacter is no longer clear. That's a nice bright yellow. And so, this organism can break down the lactose analog, showing that beta-galactosidase is present. Here's your unknown. What do you think? You tell me, is that yellow or is that clear?